Hello, myself Aditi from IIPS DAVV Indore. In this video, I am going to tell you the way to derive Simpson's rule from Newton-Cote's formula. Since we have to derive Simpson's rule from Newton-Cote's formula, so firstly we need Newton-Cote's formula. So Newton-Cote's formula is integration of fx dx from a to b is equal to nh summation I equals to 0 to n yi to the power n. Let us assume that this equation to be equation A. In this equation, ci to the power n is equals to 1 by n integration 0 to n liu du and ci to the power n is equals to c n minus I ki power n. Now, derivation of Simpson's one-third rule. To derive Simpson's one-third rule, we put n equals to 2 in equation A. So, the equation will become integration of fx dx from a to a plus 2h, that is b is equals to a plus nh. So, on putting n equals to 2, we get b is equals to a plus 2h. So, the function will be integration of fx dx from a to a plus 2h is equals to 2h summation of yi square from I is equals to 0 to 2. On expanding this equation, we get integration of fx dx from a to a plus 2h as 2h whole bracket में y0 c0 square plus y1 c1 square plus y2 c2 square. Let us suppose this equation to be equation 1. Now, further we calculate the value of variables, that is c0 square, c1 square and c2 square. So first c0 square will be 1 by 2 integration of L0 u du from 0 to 2. On calculating this, we get c0 square as 1 by 6. Similarly, c2 square is equals to c0 square. Therefore, c2 square will be 1 by 6. Now, we'll calculate c1 square, that is c1 square is equals to 1 by 2 integration of L0 u du from 1 to 2. So, on calculating this, we get c1 square as 4 by 6. Now, putting the value of c0 square, c1 square and c2 square in equation 1, we get integration of fx dx from a to a plus 2h equals to 2h y0 c0 square plus y1 c1 square plus y2 c2 square. This is our equation 1. In this equation, we put our values of c0 square, c1 square and c2 square. So, we get it as integration of fx dx from a to a plus 2h as 2h bracket में 1 by 6 as c0 square is 1 by 6 of y0 plus 4 by 6 as c1 square was 4 by 6 into y1 plus 1 by 6 as c2 square is 1 by 6 into y2. On calculating this, we get a formula, that is integration of fx dx from a to a plus 2h is equals to h by 3 whole bracket में y0 plus 4y1 plus y2. This is our Simpson's one-third formula. Now, to derive Simpson's 3 by 8 formula, we put n equals to 3 in equation A. So, the equation will become as integration of fx dx from a to a plus 3h is equals to 3h summation of yi cube from I equals to 0 to 3. As we have done earlier, in this we also find the values of C0 cube, C1 cube, C2 cube and C3 cube. So, the value of C0 cube is equals to 1 by 3 integration of L0 u du from 0 to 3. So, C0 cube will be 1 by 8. And further, C3 cube will be C0 cube. Therefore, C3 cube is also 1 by 8. Now calculating the value of C1 cube, that is C1 cube is equals to 1 by 3 integration of L0 u du from 1 to 3. On putting the values we get C1 cube is equals to 3 by 8. Now C2 cube is equals to C1 cube, therefore C2 cube is also 3 by 8. Now putting this values of C0 cube, C1 cube, C2 cube and C3 cube in this equation, that is the equation is integration of fx dx from a to a plus 3h is equals to 3h bracket में y0 c0 cube plus y1 c1 cube plus y2 c2 cube plus y3 c3 cube. Putting the values of c0 cube, c1 cube, c2 cube and c3 cube, we get integration of fx dx from a to a plus 3h is equals to 3h within bracket 1 by 8 of y0 plus 3 by 8 of y1 plus 3 by 8 of y2 plus 1 by 8 of y3. Solving this, we get the equation that is integration of fx dx from a to a plus 3h is equals to 3h by 8 within bracket y0 plus 3y1 plus 3y2 plus y3. This is Simpson's 3 by 8 rule. So, we derive the Simpson's formula from Newton-Cote's formula. I hope you understand. Thank you.